Okay, thank you very much again. Now we are just going to see and wind up the types of ANOVA. The last session on ANOVA is about two-way repeated measures ANOVA. Two-way repeated measures ANOVA. So, a two-way repeated measures ANOVA, also known as a two-way factor repeated measures ANOVA, or a two-factor or two-way ANOVA with repeated measures, or maybe within subjects ANOVA. This type of ANOVA compares the mean difference between groups, that have been splitted onto within subject factors known as independent variables. So two-way repeated measures ANOVA is the same with one-way repeated measures ANOVA, but what is special here is we will have more than one predictor variable, having two or more than two related groups. So there will be two independent variables in the case of two-way repeated measures ANOVA. And always there will be a repeated measurement of the outcome variable. So a two-way repeated measures ANOVA is often used in studies where you have measured a dependent variable over two or more than two times points when subjects have undergone two or more than two conditions. That means the time and the condition or the drug. So if we do have two or more than two measurements and plus another predictor variable in addition to time, a condition or a drug or any type of intervention. So there will be two and more than two independent variables, at least having at least two related and more than two related categories. Each independent variable will have at least two related categories or more than two related categories. So in order to say two-way repeated measures ANOVA, we need to have at least two independent variables of categorical in nature, which are related. But the outcome variable, as usual, is always a continuous single predictor outcome variable. So the primary purpose of a two-way repeated measures ANOVA is to understand if there is an interaction effect between the two independent variables, So we are going to test the main effect of the first variable, the first predictor variable. We are going to measure again the main effect of the second predictor variable, and third we are going to measure the interaction effect of the two predictor variables. That is so it is different from two-way ANOVA because there are repeated measurements in this case. Okay. And here again, it does have its own basic assumptions and requirements. Most of them are the same with that of the one-way repeated ANOVA. So the dependent variable should be continuous, and our two within factors or within subject factors or the independent variables should consist of at least two categorical related categories, or groups. So we do have two independent variables, and each of these independent variables should have two categories which are related, and more than two. It might be more than two. So related groups indicate that the same subjects are present in both the groups, as I have said it repeatedly. So the reason that it is possible to have the same subjects in each group is because each subject has been measured on two occasions on the same outcome variable. The third assumption, there should not be a significant outlier. The fourth assumption, the outcome variable should be normally distributed. And the fifth and the last one is there should be assumption of sphericity, which is similar with the one-way repeated measures of ANOVA. So the variances of the differences between all combinations of related groups must be equal. That is the sphericity. Unfortunately, SPSS statistics makes it easy to test whether your data has met or failed to the sphericity of assumptions. So this is overall the idea of two-way repeated measures ANOVA. Thus, what is special from one-way repeated ANOVA is in the case of two-way repeated measures ANOVA, we do have two independent predictor variables having at least two related categories. So we do have another example, the same example, the previous one, but with an additional predictor variable, A researcher was interested in discovering whether a short-term, 2-week, high-intensity exercise training program can elicit reduction in the marker of heart disease, which is called the C-reactive protein. So to answer this question, the researcher recruited 12 individuals and had them perform two types of trials, treatments. One, a control trial without any exercise program, and an intervention trial, the second trial, you see. So the type of treatment is having two categories: the control trial without any physical exercise program, and the intervention trial, that means with the exercise program. So the treatment or the intervention is without exercise and with exercise, having being categorized in such a way, which were counterbalanced and with sufficient time between trials allow for residual effects to dissipate. We need to have just an optimal level of or optimal level of time intervals between each measurement, So in the control trial, subjects continued their normal activity, while in the intervention trial, they exercised intensely for 45 minutes each day. But the study subjects are the same, During the control period, they only continue their normal activity. And what was measured is the C-reactive protein level. Okay, during the intervention trial, after the intervention has been started, after they have been engaged in the exercise program, for each day they exercise intensively for up to 45 minutes. So the same subjects were measured on the CRP level during the control period and during the intervention period. So the type of treatment or the intervention is one predictor, and the time at which the measurement was taken is the time by itself is a second predictor variable. The CRP concentration is outcome variable. So CRP concentration was measured at 3 points in time: at the beginning, the midway, and at the end of the trial. This has been done during the control period and during the intervention period. So 3 times CRP concentration level was measured 3 times during the control period, and CRP was measured 3 times during the intervention period. For the control trial, the two within subject factors are the time and the treatment, you see? So we do have two predictors now. The treatment is being categorized as control and intervention. The control and intervention. Okay. And the dependent variable is the CRP or the C-reactive protein level. Okay. So time will be categorized or grouped as, you see, the beginning, the midway, and at the end of the trial. So 3 time points. The time is categorized into 3 categories: at the beginning of the control period, at the midway of the control period, and at the end of the control period for the control one. During the intervention, at the beginning of the intervention, at the midway of the intervention, at the end of the intervention. So time is categorized as having 3 categories. But the treatment is only having 2 categories, that is the control and the intervention. So 2 predictors having 2 and more than 2 related groups were included in this example. And the outcome variable is the C-reactive protein concentration level, which is measured as continuous. So in variable terms, the researcher wishes to know if there is an interaction effect between time and treatment on the C-reactive protein level. So the interaction, is there an interaction effect between the treatment and the time? Because time by itself does have an effect on the outcome of a certain disease, Okay. So now let's proceed. This is the way how we are going to do a two-way repeated measures ANOVA using SPSS software. So here are the procedures, similar with one-way repeated measure ANOVA, but what is special here is we are going to add 2 predictor variables here in this box. The box which is displayed here in the PowerPoint. In the one-way ANOVA, we are going to one-way repeated measure ANOVA. We only insert 1 predictor variable having 2 or more than 2 levels. But in the case of 2 repeated measurement ANOVA, we are going to add 2 predictor variables here. How we are going to add, we'll see in doing SPSS, So in the dependent box, we'll put the dependent variable and the independent variables, two variables. The treatment and the time should be placed there. So thereafter, these procedures will follow, similar with the previous one. Okay. So I think it's better to go for demonstration of the data set using SPSS. So this is a way how you are going to use, just to show you the procedure of doing a two-way repeated measures ANOVA using SPSS.